Hi, my name is Ann MacMillan-Crow, and I want to tell you a little bit about the research that's taking place in my laboratory. The main focus of our lab is to understand the extent of kidney damage that occurs during transplantation. So let me tell you a little bit about the transplantation process. When people get a transplant, most people get kidneys from two different types of donors. One donor can be from a deceased donor, which is the most common and the most common type of donor. However, you might have seen in the news lately, more and more people are receiving kidneys from living people, so living donors. And it's quite interesting that if you look at success rates post-transplantation, the people that receive kidneys from living donors do much better. The kidney function is stable for a much longer period of time compared to the people receiving kidneys from deceased donors. So my lab has been interested in understanding what is the difference between living donors and deceased donors. So what we've spent quite a bit of time on is looking both in human populations, the human kidneys, as well as animal models of transplantation injury, focusing post-transplantation all the way down to just what happens when kidneys are placed in cold storage. It's thought that the cold storage process actually helps preserve kidney function. However, more and more research from our laboratory as well as many others across the country have understood that cold storage is not without harm. That's not to say that kidneys don't need cold storage, but one main emphasis of my lab is to understand why does the damage happen during cold storage and what can we do about it. We've recently obtained a grant from NIH, a small business type grant, to test a compound that is targeted to mitochondrial oxidants that might help prevent injury that takes place during cold storage. So that brings me to another focus area of my lab. My lab has been interested for the last 10 or 15 years in mitochondrial oxidant production that takes place during both cold and warm renal ischemia. So again, mitochondrial oxidant production can be controlled in a very discrete way by an enzyme. That enzyme is called manganese superoxide dismutase. My work as a postdoc actually began discovering that manganese SOD was targeted for inactivation in human kidney transplantation injury. And we've kind of maintained that focus over the past 10 or 15 years to understand why is that. What happens to when you lose manganese SOD function? Why does that cause injury? And most recently, we have focused on making a kidney-specific manganese SOD knockout mouse. This will provide us, without any ischemia, provide us what happens with renal damage when you just knock out this enzyme only in the kidney. So that's one main emphasis of my lab, is to evaluate that model with and without renal ischemia. Another focus of research in my lab is to use renal cells. So we use both animal models and renal cells to understand the effects that oxidants have on damage. And again, we can also evaluate antioxidants to see can we prevent that damage from occurring. So there's quite a bit of research that students and postdocs can perform in my laboratory. So I want to tell you a little bit about my lab on a personal basis. It's a fairly small lab. I like to get in the lab on a daily basis. I'm in there. I wish I was in there more actually doing experiments. However, I can live through the students in my lab and the postdocs in my lab and help evaluate, troubleshoot their ongoing experiments. I currently have 3 graduate students, 1 postdoctoral fellow, and one lab manager. If you're interested in any of the research that's taking place in my lab, please feel free to take a look at the website, contact me. We love to recruit more people that are energetic and have a passion for research and just like having fun doing lab work.